In the triangle that you see, it is an acute triangle, and I have labeled the 3 angles and the 3 sides. So what it says at the top of your sheet there, please follow along at the top of your sheet. If you know any 3 measurements of an acute triangle, so here there are 6 options for measurements that you can know. If you know any 3 of them, including at least one side, so of those 3, one of them has to be a side, then you can find the remaining measurements using sine law or cosine law. So with just 3 measurements, as long as one is a side length, you can solve any acute triangle. The choice of sine law or cosine law depends on which law allows you to relate the 3 given measurements to one unknown measurement. So to explain that, we're going to rewrite the sine law. Go ahead and write the sine law for yourselves where it says sine law. You can check the board to see if you're doing it right.
Have a pen. If you're going to shoot. Yeah. No, I was like, oh. I know, I'm kidding.
And what is the cosine law? Has anyone memorized cosine law yet?
Isn't it a squared equals b squared plus c squared
Minus
2ab cosine
No,
a.
BC cosine A.
It actually does
Yeah,
work.
BC.
It actually does work. Like if you say it with the negative b sound.
Negative B.
It actually works. If you say it, it actually does work. I tried it before.
How does that work?
I wouldn't confuse songs. I would just, if you want a song to remember, you can make a new song. But here we have our sine law and our cosine law, and using these 2 laws, as well as one property of a triangle, that is that the sum of interior angles of a triangle add to 180, you can solve any acute triangle. Now what we mean by being able to relate given information to the information that you're trying to find is that in order to say solve for B, the side length B, and using sine law, we would need to have the angle B and then either the angle A and the side length A or the angle C and the side length C. So that's what it means that you need to be able to relate 3 pieces of information to the missing piece of information. Same thing here. We have a missing piece of information, but we have 3 pieces of information. We have B, we have C, and we have the angle A. So we have 3 pieces of information, and they relate to a 4th piece of information. And if we can make that kind of relationship, then we can solve the triangle. But we still have to know when it's best to use cosine law and when it's best to use sine law. So down in your page again, consider the acute triangle above with each side labeled S and each angle labeled A. When determining the best strategy for solving an acute triangle, we consider the information that we know. Often we use short forms, pay attention, like SAS, to identify what pieces of information we know. So the short form SAS means that you have been given 2 adjacent sides and their contained angle. So if you look around your triangle, doesn't matter which way you go around, if you have SAS, then you have 2 sides and their contained angle, so the angle that falls in between them. If you have the short form SSA, that means no matter which way you're going around the circle, you have side, side, angle. So you always go in order of the acronym. Side, side, angle is SSA. Okay, other acronyms would be ASA or ASS or SAS. Okay, so those are all the acronyms for the 3 pieces of information that you need to solve a triangle. Okay, we're going to look down the short form. What strategy would you use to solve a triangle when given the following information? So you have a table there, and you have a few short forms, and they tell you which information you're given, and you can figure out, we're going to think through how we would solve each of those triangles. So for instance, if you had side, side, angle, think about what side-side angle looks like. I actually did it in pink already. Side-side angle. Which law, sine law or cosine law, would you use? How do we know that we can use sine law? Because we have an angle and the opposite side length measurement. So we already have one of these ratios. We have another side length. So in this scenario, we would be solving for the angle B over here. Once we had that, we could use our other skills to solve for the other sides. We'd have three angles. Then we could use the sum of the angles is 180 to get this angle, and then we could use sine law again to get this side. Okay? So if you have SSA, you can use the sine law right away because you have opposite information. Good? What about if you had SAS? And that is done in blue on my triangle.
What does that say?
Use sine law over here for SSA. Yep. What about if we have SAS? So we have two sides and the contained angle.
Cosine.
We need to use a cosine law there. In order to solve for this side, we need to use its opposite angle and the two other sides. So if you have an SAS pattern, you're using the cosine law.
So why would you not use sine law?
If we have SAS, then we cannot use sine because we don't have any opposite information.
Sorry.
Alright, let's look at angle, side, angle. So that would be something like this. Angle, side, angle. How would we solve that one? This one's a little bit trickier. Can we use the sine law? Do we have opposite information? No, none of the three situations. What about cosine law? Well, cosine law says that I need to know two of the sides. Do I know two of the sides? No, I only know one of the sides. But there is another strategy that we can use. What's
Is there
in?
tan law?
There's not a tan law. Good question, though. What about
Can
these?
we add the angles?
Oh, can I get this third angle simply by using the sum of angles in a triangle are 180? So the sum, here we can go angle A plus angle B plus angle C equals 180. So then we have all three angles. Now what would we do? If now all of a sudden we have this angle as well.
Sine.
Now we have opposite information, right? So we can use our sine law.
Cosine.
The last one that we're going to look at is what if we have side, side, side. So I've got side, side, side. Can I use sine law? No, I have no opposite information, so I can't use sine law. I have no matching angle and side. What about cosine law?
Yep.
Cosine law says I have to have two sides and an angle. Well, I don't have any angles, I just have three sides. Can you think of a solution for this problem?
Nope. Use a protractor.
Some tan law.
There is no tan law. That's right. Well, you can use like tangent or the theta thing.
No,
Find an
probably works
angle.
Right angle.
Only works in a right angle triangle.
Alright.
Oh, we're gonna split the triangle in half.
We're not going to split the triangle in half.
Half base times height. Oh. Rear.
Rear.
Range.
Ah. Because we have three sides. So we can
And then that's what we're going to learn today.
Good, so we can rearrange the cosine law to solve for this angle using our three sides that we know. So that's what we're going to look at today in lesson 8.3, finding angles using the cosine law.
Is it the SSF
Okay, yep, we're talking about how can you solve an acute triangle if 3 side lengths are given. We decided we couldn't use sine law because we don't have opposite information. We can't use the cosine law as it is, but we can manipulate the cosine law. We can rearrange it. So let's write the cosine law down at the bottom of your first page. You've got a squared equals b squared plus c squared minus 2bc times the cosine of a. So our goal here is to rearrange so that we are solving for a. So we're going to actually get this whole bracket, the cosine of a, to be by itself and all this other stuff to get moved to the other side. So using our algebra skills, what has to happen first? Now I know 2bc cos a are all connected by multiplication. So I can't really deal with them right away.
Are you recording? No. Okay, no, you divide it.
So that's true. When we get to a real problem, we could put in what we know and then rearrange it. Or you can rearrange it and then put in what you know. So this time we're rearranging. I'm going to show you that it rearranges nicely. And then there's 2 formulas.
B and C. We already subtracted.
No, but then you divide 2bc from a.
So what I'm going to do, just because this is negative, I'm actually going to add this to the other side before we start. So we're going to just be left with a squared. We're going to add 2bc cos a to both sides. Please go ahead and copy this down. So we have a squared plus 2bc cos a is equal to b squared plus c squared. I'm just going to switch markers here. That one's not working so nicely. Now I can subtract a squared from both sides to get this chunk by itself. So we're going to, on the left, we've still got 2bc cos a. That's all multiplied by each other. And here we have b squared plus c squared minus a squared. Now I can divide this whole side by 2bc. So if I divide this whole side by 2bc, all I'm left with is the cosine of a. And on this side, we have to divide this by 2bc. Then all this part stays in the numerator. b squared plus c squared minus a squared over 2bc. And all that means is 2 times the side length b times the side length c. And there we have it. That is the cosine law rearranged to help us solve for an angle when we've been given 3 sides. So this helps us to do any situation, any acute triangle we've been given SSS. And if you plug in what you know, you'll end up with cos A equals some ratio, some number, and then you just do the inverse cos of that number to find what the measure of angle A really is. We're going to dive into a few examples. So here's example 1. We're going to be finding an angle using the cosine law. It's a simple practice question.
3 towns are connected by 2 roads, as shown. A third road is planned that will directly connect Brookside and Highcliffe, which are 16.5 kilometers apart. Find the angle to the nearest 10th of a degree between the new road and the existing road, from Rolling Meadows to Brookside and Rolling Meadows to Highcliffe.
Alright, so we are finding 2 different angles here. We've been given 3 of the sides. So let's go ahead and draw a simplified diagram. We're going to make our diagram look pretty much the same, but we're going to take out the names of the towns and just keep labels.
We're using that line.
Pardon?
What if you already know the answer?
So we have a B for Brookside. We have an R for Rolling Meadows. And we have an H for Highcliffe. We know that the road between Rolling Meadows and Highcliffe is 15 kilometers long. And we know the road between Brookside and Rolling Meadows is 10 kilometers long. And in the question, it told us that the road between Brookside and Highcliffe that's being built is going to be 16.5 kilometers long. So here we have an acute triangle. We've been given side, side, side. And we need to use our cosine law in order to solve for the angles. Which angles are we looking for? We're looking for the angle made at Brookside. And we want to find the angle between Rolling Meadows and Highcliffe. So we're looking for H. So we know how long this road is going to be, but we don't know at what angle it's going to make with the road at Highcliffe, and we don't know the angle that it's going to make with the road that meets in Brookside. So here we go. We're going to do this two different ways. The first way we're going to do it is to substitute what we know and then rearrange. The second way that we're going to do it is to rearrange and then substitute. So first, on the left side of your page there, I've separated it into two things. You've got method 1, which is sub, then rearrange. Substitute, then rearrange. So we have our cosine law, and we're just going to write it as we have it, but we're going to use the labels that we have. So this is side B, this is side length R, and this is side length H. So because we're going to solve for angle B, we're going to solve for angle B in A. Then we need to put B squared first, because cosine of B has to be our missing variable on the right side. So we've got B squared plus the sum of the squares of the other two sides, that's R squared plus H squared, minus 2RH times the cosine of B. The next step, all we need to do is sub in what we know. So we know B, R, and H. So go ahead and sub in those values. We have 15 squared is equal to 16.5 squared plus 10 squared minus 2 times 16.5 times 10 times the cosine of B. No, all going down the left side. All going down the left side, and we'll do the right side after.
And is the A in bracket supposed to be times by B, or is that...
No, that just means that we're doing example 1A. Yep.
Mr. B, wouldn't it just be easier to rearrange and then sub it all in?
I think so.
Okay. Why not just do that?
Because we're going to do it both ways. And now we simply have to use our algebra skills to simplify. So let's take care of our exponents first. 15 squared is 225. 16.5 squared is 272.25. 272.25. 10 squared, you should know that. And then we'll also reduce this group of multiplied numbers. We've got 2 times 16.5, which is 33, and times 10, which is 330. So over here we're left with 330 times the cosine of B. Doesn't matter. So the question is, should the cosine of B be in brackets? Doesn't matter. This means 330 times the cosine of B. Remember, in algebra, the default operation is multiplication. So if there's nothing in there, it's multiplication. But for clarity, sure, we can bracket that. Okay, let's simplify a little bit further. Let's get our 225 still on the left. 272.25 plus 100 is just 372.25, and we still have minus 330 times the cosine of B. now we can move this 372.25 to the other side by subtracting it from both sides. Okay? So we're subtracting 372.25 from both sides of the equation. 225 minus 372.25 is negative 147.25. And that is going to be equal to negative 330 times the cosine of b. Remember, our goal is to isolate b. So we're going to isolate the cosine of b and then take the inverse cos of b. In order to do that, what's my next step, Amy? Yeah, let's divide both sides by negative 330. Make sure you keep that negative sign with the 330 so we can get rid of it. Which means on the right, we're just left with cosine of b. And on the left, we're left with 147.25 over 330. Now we didn't divide that out in our calculator because it would be a decimal answer and we'd end up rounding too early. We don't want to round. We can actually put this in our calculator when we take the inverse cos of both sides. So let's take the inverse cos of both sides, which leaves us on the left with the inverse cos of this ratio, 147.25 over 330. And on the right, we'll just be left with the measure of angle B. And we can plug this in our calculator. Go ahead and try it in your calculator. You should have a calculator. You need your calculator. You get an infraction next time you don't have your calculator. That's really easy. So you need to make sure that this ratio is in a bracket. Otherwise you'd just be doing the inverse cos of 147.25 and then you'd be dividing that by 330, but that's not what we're trying to do. This is the ratio, so this whole thing needs to be in brackets and you inverse cos it. You should get that the angle B measures to 63.5 degrees. So, to answer question A, the new road will make an angle of approximately 63.5 degrees with the existing road from Rolling Meadows to Brookside. So right here we're looking at 63.5 degrees.
You need to start writing in pencil or get your own whiteout.
I'll get my own whiteout.
Liar.
Eventually.
Okay, we are going to solve for the same angle, angle B, using a second method. This second method is to first rearrange on the right side of your notes there, then sub. Now we have already rearranged it in our notes, so we are just going to go ahead and use that formula that we've already rearranged. So we're solving for B, so we want to have the cosine of B on the right, and that is going to be equal, according to our second cosine formula, b squared. We wrote ours differently though. We wrote h squared plus r squared minus b squared all over 2b 2rh. So here we have our opposite information, the one that we don't know and the side length that we do know. We know the two other sides. That's why they're involved in the sum and in the product in the denominator.
Couldn't you use that method for the first one?
This is the first one. We're literally doing the first one again, using a different method. Yes, we're solving for angle B. Okay, good. So now we have our cosine formula. So all we have to do is sub in our known information. Well, we know that h is 10, So we've got 10 squared. We know r is 16.5, and we have that squared. Then we're going to subtract b squared, which is 15 squared, and that's going to be all over 2 times 16.5 times 10. This whole numerator you can just put right in your calculator. It's going to be 10 squared, which is 100, plus 16.5 squared, minus 15 squared, which is 225. And the result that your calculator will chuck out at you is negative 147. Sorry, it'll be positive 147. Positive 147.25 over 330.
Oh, I see. What are we doing right now? Figuring out another angle?
Nope, we're doing the right side of, we're doing method 2 for solving for angle B. So we're still doing A, still A, but we're using a different method. So this time we're rearranging the cosine law to make it look like this,
So are we double checking?
and then subbing it in. We're not really double checking, I'm just showing you that it can be done 2 different ways, and you on your homework can choose the way that suits you best. Okay? Now, because of this, we can take the inverse cosine of both sides, which will tell us that the angle B is equal to the inverse cosine of the ratio 147.25 over 330, which equals, as we found out before, 63.5 degrees.
Isn't that way shorter?
This is shorter if you have memorized the rearranged formula. If not, you still have to use the cosine formula that you've memorized and rearrange it and then sub in. Okay, so we skipped that part because we just finished rearranging it to get the second formula in our notes. Okay, so we've solved for angle B. We've shown that we can do it 2 different ways. You can choose the way that suits you best on your homework. But now we need to solve for angle H. What should we do? Yeah, we could use cosine law again, but cosine law is a bit messy. Now that we just found angle B, we have opposite information, which means that we can use the sine law. So for question B, which is finding the angle H, we can just use sine law. We can say the sine of B over B is equal to the sine of H over H. We have 3 known pieces of information and 1 missing piece of information. So we can write down what we have. Sine of B is sine of 63.5 degrees over side length B, which is 15. And that is equal to the sine of H over the side length H, which is 10. We're fairly familiar with how to use the sine law. How am I going to get sine H by itself, Steph?
First you have to find out what sine 63.5 is, and then you just divide it, and then times it.
Okay, so we could do it step by step. We could definitely go sine of 63.5 divided by 15 and then times by 10. Sometimes what that leads to is rounding in your calculator and on your page and losing some information. So really,
Just do it like that.
yeah, so all we have to do, if you do it in your calculator, so I just want to write down what we would write in our calculator. Basically all we would have to do here is multiply each side by 10, which would cross those guys out, which would give us that sine of H is equal to 10 times sine 63.5 over 15. Now it doesn't really matter what order you punch it in your calculator, as long as you do 10 times sine 63.5 divided by 15. Or you could do sine 63.5 divided by 15 times 10. Any order works. This reduces to a decimal of 0.5966, and it carries on. Ideally, you'd be able to store all that information in your calculator And then to solve for the measure of angle h, we take the inverse sine of both sides. And on your calculator, you might just be able to take the inverse sine of answer. Some of your calculators you'll need to punch in 0.5966. And you will get an approximate answer for the measure of angle h. Anybody with their calculator ready to go?
I got
36.6.
There you go. You should end up with 36.6 degrees, which tells us that the new road at Highcliffe is going to make an angle with the old road of 36.6 degrees. And we have solved both of those missing angles. One using cosine law, second using sine law. If we needed to solve the third angle, what would you use for the third angle? Can't use Pythagorean theorem because it's not a right angle triangle, but the sum of interior angles in a triangle is 180. So you just add these up, subtract it from 180, and you'll get R. Going to take a look at example 2, and we're going to first draw a simplified diagram. So try to think about what's happening here. Runners in a 10-kilometer race follow a triangular course. So we know that the perimeter of the triangle is 10 kilometers. The three legs of the race, that's going to be the three sides of our triangle, in order are 3.8 kilometers, 2.4 kilometers, and 3.8 kilometers. Ooh, what do you notice right away? Yeah, it's an isosceles triangle, right, with two sides that are equal. We need to find the angle between the legs in each pair to the nearest degree. So all that is saying, find the angle between the legs. That's all the angles, okay? So let's go ahead and draw what we think our triangle looks like. We've got our first leg is 3.8 kilometers. So just draw any old line and call it 3.8 kilometers. We'll start at point A, and that leg will end at point B. We know our third leg is also 3.8. And our second leg is a bit shorter. Our second leg is 2.4. So I'm going to try to make this look like an isosceles triangle, like we know it's supposed to. We'll call this one 2.4. That's our second leg. That's going to end at point C. And they're running on a track, so once they get back to the beginning, they will have run another 3.8 kilometers. I want to have my unit of measurement in my diagram. And in A, we need to solve for the angle between the first leg and the second leg. So which angle are we solving for there?
C?
We're solving for the angle between the first leg and the second leg. Yeah, so we're solving for B in this one. So first and last A, we're going to solve for angle B.
What does it think? 2.4?
Yeah, 2.4. Okay, we've been given side, side, side. So what strategy do we need to use if we've been given side, side, side? We are going to need to use cosine law. And can I use it in its original form?
Yep.
We can, and then rearrange, or we can use it in its other form. So I'm just going to use it, we'll write it both ways just so that you can see it again, how it works. We are going to have b squared because we're solving for angle B. So we're going to start with side length b squared equals a squared plus c squared. That's the square, the sum of the squares of the other two angles, minus 2ac times cosine of angle B. And we
How
said,
do you know which one to cosine, like in that bracket?
how do I know which angle is here?
Yeah.
Well, this is the angle that we're finding. And in yesterday's lesson, we talked about how we noticed that the angle that we're finding and its corresponding side length bookend this formula. So it starts with B and it ends with B. And then we had A and C in between twice. And those are the other two sides. Yeah, so the easiest way to remember it is if you're solving for B, then B has to be on the outside as well. If you're solving for angle A, then the side length A needs to be on the outside as well. We said that this could be rearranged in order to solve for cosine of B. So we'll write down our rearranged formula, which is, and theirs is a little bit different than the one I wrote for you the first time, but B squared minus A squared minus C squared over negative 2AC. I like mine better, but this will work. Okay, so side length B is over here, so we've got to sub in what we know. Cosine of B is equal to B squared, which is 3.8 squared, minus A squared, 2.4 squared, minus C squared, which is 3.8 squared, all over negative 2 times A, which is 2.4, times C, which is 3.8. We sub in what we know, and now we can get to our calculator. We get, on the left side, we still have cosine of B. It's going to be equal to, the numerator reduces to negative 5.76. Negative 5.76. You're able to just chuck this, no matter what calculator you have, you can chuck this whole thing in your calculator. And it will do it for you. The denominator reduces to negative 18.24. And we don't want to round too early, so we're going to take the inverse cos of both sides, leaving us on the left with just the measure of angle B is equal to the inverse cosine of negative 5.76 over negative 18.24. Again, it's not difficult algebra. You just need to be very careful with your squares, with your positives and negatives, and keep track of it all. If you put this in your calculator, you will come out with a measure for angle B of approximately 72 degrees, and that's rounded to the nearest degree. So the angle between the first leg and the second leg, which is called angle B, is approximately 72 degrees. Well, now we know this information. We've got 72 degrees here. We need to solve for, in B, the angle between the second leg and the third leg. So now what strategy are we going to be using in order to solve for angle C?
We have sides S, A, S. Side, angle, side.
Okay, so we're solving for angle C,
Cosine law.
and we don't need to use cosine law again, because now we have, look, we have angle B and side B. We have opposite information. So Vanessa, which law are we going to use if we have opposite information? Yeah, we're going to use sine law. Sine law is a little bit quicker and easier to use. We have our given ratio. We've got the sine of B over side length B. We're solving for the sine of C. That's going to be over side length C. Sub in what we know. Sine of 72 degrees over 3.8 is equal to the sine of C, which is still unknown, over 3.8. We are going to multiply both sides by 3.8, which is going to cancel out, actually it's going to cancel out on both sides. You'll see what happens here. Multiply this by 3.8, multiply this by 3.8, cancel out numerator and denominator here, and 3.8 in the numerator, 3.8 in the denominator, they cancel out. So the sine of angle C, is equal to the sine of 72 degrees. a couple ways to think about this. You can take the inverse sine of both sides, and what will happen is you'll just take the inverse sine of this side, will cross out the sine, and the inverse sine of this side will cross out that sine. C equals 72 degrees. And that makes sense, of course, because we had already determined that the triangle that the track made is an isosceles triangle. So these two side lengths are equal, which makes these two angles equal. Okay, we're almost done solving this triangle. We have one more angle to find. It's the angle between the third leg and the first leg. So we're solving for angle A.
But we already have this angle C and angle B.
So in C, we're solving for angle A. We already have angle B and angle C, so what can we use? The sum of interior angles in a triangle is 180 degrees. So, angle A plus angle B plus angle C should equal 180 degrees, which means angle A is equal to 180 minus angle B minus angle C. Sub in what we know. Angle A is equal to 180 minus 72 minus 72. That's 180 minus 144, which leaves us with a measure of angle A of 36 degrees. This triangle is solved. Key concepts? Key concepts. You can rearrange the cosine law to find an angle. To find an angle if you know three side lengths of an acute triangle ABC.
What about sides? How does it have these side lengths?
Side lengths. Yep, because just because I know you doesn't mean I know your length.
What is going to be a lot of problems over in a minute, I think.
Can we finish this first and then talk about it?
Maybe.
Okay. Once you have found one angle, you can apply the sine law. So using the cosine law to find one angle. Once you found it, you can use the sine law, which is a little easier, to find the second angle. To find the third angle, apply the property of triangles that states...
All interior angles are equal to 180 degrees.
You got it. The sum of interior angles in a triangle is 180 degrees. The sum of interior angles in a triangle is 180 degrees, or
Is that what you write on
A
the
plus B plus C equals 180.
Yeah.
The sum of the interior angles in a triangle is 180 degrees. And the last one, when solving trigonometry problems, there is often no valid strategy? No.
Many. Two.
Several. Yeah. There are often more than one valid strategy. There is often more than one valid strategy.
What would be strategy?
No, like I thought.
All right, your homework is down at the bottom of the page there, page 373, number 2, 3, B and C, 4, 5, and 10. Please do your best and come to class with questions and completed homework.